So here, we have a piecewise defined function, right? And this is sort of just like the quiz, sort of as far as we can remember.
And for the viewer, that these are quizzes that are issued by people from Santa Monica College, unpleasant people.
Anyway, that is useful, I guess. But
Yeah.
so hopefully in the future, if you're engaging in quiz warfare with Santa Monica College people,
these videos should come in handy.
Yeah. Okay. Here we need to first of all graph this piecewise guy, and then we're looking at the limit as x goes to 1. And it makes sense because x equals 1 is sort of the screwy part of this function. Okay, so here we go. So first things first, we're going to graph this guy, and I'm going to zoom out, maybe keep the problem itself tucked up here in the corner. And then I'm going to pause the video and draw some axes. And lo and behold, some axes magically appear through the miracle of pause. So how are we going to graph this guy? We see the first thing we have to take care of is negative x squared. We're going to do that for x strictly less than 1. We kind of have an idea that negative x squared is a parabola that looks like this. If it stops at x equals 1, then we're expecting it to look like this. But let's take it all the way back to 7th grade and make sure that we actually know what's going on. And so to do that,
Deja vu.
I'm going to make a t-chart, which is like sacrilege. You know, you're supposed to use all these fancy function graphing techniques. Anyway, not so fancy technique. That's the phone. We should hit pause. So, phone call handled. Important to note is that x is less than 1, which means we're going to make a big note right here that this point is going to be graphed. Okay. You gonna be alright?
Yeah.
This point will be graphed.
I didn't get you, did I?
No, I'll be fine.
Yeah.
I'm going down.
Yeah.
I'm going down.
Yeah.
The values of x because x is less than 1.
Yes.
Right? Okay. And now I'm just going to do this really fast. 0, -1, -4. And we're going to plot these like so. This is going to be a hole. Followed by
I should have bought NyQuil.
what we expect.
Sorry. I don't know, that just tickled me.
Whoever is watching this, you're getting free calculus help, so they can handle it if you sneeze a little bit. Alright, so,
Yeah.
alright, hopefully it's kind of clear what I did there. The point that I'm making is how careful I was to pay attention to what's going on with x less than 1. And I also didn't
Well, I mean, it's very important to get, you know, if you get the graph wrong, then everything else will be wrong too.
Exactly, and the details like domain stuff, you know, these open holes versus closed holes, that kind of stuff matters a lot in calculus. Okay, this part being the next part.
Yes.
When when x equals 1, the function value is 2. So in other words, f of 1 equals 2.
Yeah, so that's the point 1, 2.
Right, so that's the point 1, 2, and that's all we have to do for that particular
Just plot that part.
that particular thing, and so we're going to color that in. There you go.
Time to save it again.
You think so? Oh yeah, we don't want to get burned. So again, if the viewer wondering, we have to save this because we're recording it on an iPad that decides to freeze and ruin our work. Okay, so finally we've got x bigger than 1 with x minus 2, and so I'm going to make another one of these t-charts here. I've got x, then x minus 2. X is going to start at 1 and it's going to get bigger, and then we're going to make clear that this is a hole. Okay. Etc., etc. Alright, so Let's zoom in, plot those points. This one we see agrees with what we had before.
Yes.
1 comma negative 1. And there we go. Again, you can be more sophisticated. You can say, oh, this is a line with slope 1 and y-intercept negative 1. We're not so smart. You just plug in points. Now, there we go. There's what's going on. So essentially we are done with problem number 1.
Yes.
All right, on to number 2. Now number 2 says, does limit as x goes to 1 of f of x exist? Okay, this is a loaded question.
Yeah, you can divide it into 2 parts.
In fact, you must divide it into 2 parts. So right away, we're going to highlight this question as one that we cannot answer without doing some preliminary investigation.
Trust the process.
Exactly. And what that means is we are going to have to look at limit as x goes to 1 from the negative side of f of x.
Otherwise known as the left side.
Limit as x goes to 1 from the positive side.
Otherwise known as the right side.
Okay. The first thing I'm going to do is I'm just going to do this on the graph. And then we'll also look at this with formulas.
Yes.
Okay. If x is going to 1 from the negative side, what does that mean? That means, oops,
Is there undo?
I just did, I just undid. Okay, I got to rewrite that. Anyway, what I should do is erase. It's not even working. This program is screwy. Limit x goes to 1 from the negative side. Okay, sorry about that. This right here means x is less than 1. And this right here means x is bigger than 1. Alright? I'm going to use this red pointer thing to demonstrate what we're doing with x less than 1, but approaching 1. I'm going to zoom in. Okay? We are looking slightly to the left of 1, but we're doing it on the function. And we're going to approach 1 from the negative direction.
As in y would go to negative 1.
Exactly. And when I say approach 1, what I'm actually doing is I am approaching over the values that x takes from to the left of 1, and then of course on this side we would be approaching 1 from the positive direction. Right. And at the end of the day, we actually get to 1. We don't care that it's an open hole, but we do see that the y value is negative 1. And we can do the same thing as we are approaching from the right. We see that the y value is negative 1. What we don't care about is what's actually happening at 1. The people who are investigating the limit, the imaginary people who are getting very close to 1. There's the guy on the left of 1 and the guy to the right of 1. They don't care about what's happening at this point. All they care about is that over here on the y-axis we're approaching negative 1 in both directions. Alright, maybe that's overkill. Who knows? But the point is, from the graph, we can figure out that this guy right here, the first one, is negative 1, and the second one is also negative 1. Okay? Now, what if I had to do this using the formulas? What if I didn't have the graph? Well, x going to 1 negative means that x is smaller than 1. Which means I'm going to use this formula. Which means I'm going to plug 1 into this formula. I'm going to get negative 1 and we're good to go. Again, x smaller than 1. I go to my piecewise list. There's what tells me to use which formula. I'm going to use negative x squared. Plug in 1 to negative x squared, I get negative 1. Ditto for x bigger than 1. I go to my list of choices. I pick x minus 2 because that is the one that goes with x bigger than 1. X minus 2, when I plug in 1, gives me negative 1. Another way to figure out that these two limits are both negative 1. So we have thus completed what we need to do to investigate this question. The answer now is yes. The limit does exist. And the reason why the limit exists is because
Those two are the same.
right, the one-sided limits are equal. Okay? Okay? And if so, what is it? The answer is obviously negative 1. Okay? Now, to the punchline of this whole thing, what is f of 1? Okay, so f of 1 here is 2. So we haven't learned the next word that I'm about to throw out there, but I'm going to put it here anyway. Maybe a couple of vocabulary words. You would say that in this case, I'll write this in a new font or new color, blue. We would say f of x is discontinuous at x equals 1. And the reason why is we would say limit x goes to 1 of f of x exists, and f of 1 exists. Okay, those are 2 of the 3 criteria for continuity, which we haven't even talked about, but I'm throwing this out as an example just so you can see the words being used in conversation.
Yeah.
We have 1 and 2, where 1 and 2 are 2 criteria of continuity, but criterion 3 fails. They are not equal. Okay, so there are 3 criteria for continuity at a point. They are that the limit has to exist, the function value has to exist, and the 2 are equal, but in this case, they are not equal. There we go. Careful.
There we go.
As careful as you can be through, this is probably like the most boring, careful graphing of a piecewise function ever. But it's good because,
Yeah, I mean, that's what you need.
there you go.